Hello everyone. Welcome to the Syed School. Today we will learn about IPv4 addresses. IP address. An IP address is like a unique address for your device on the internet. It helps computers and other devices communicate with each other. Think of it as the postal address for your online activities. Every public IP address in the world is unique and does not match with any other device. IPv4, Internet Protocol version 4, is the older version of IP addresses and is still widely used. It uses a 32-bit address format, which means it can support a total of 2 to the power of 32, 4,294,967,296 unique addresses. Here's a breakdown of an IPv4 address. For octets, an IPv4 address is divided into 4 octets, each representing a byte, 8 bits. Dotted decimal notation. IPv4 addresses are typically written in dotted decimal notation, where each octet is represented as a decimal number separated by dots. Example of an IPv4 address, 192.168.1.1. IPv4 addresses are divided into 5 classes based on the first octet. Class A, the first octet ranges from 0 to 127. These addresses are typically used for large networks, such as those belonging to major organizations or governments. Class B, the first octet ranges from 128 to 191. These addresses are commonly used for medium-sized networks, such as those of businesses or universities. Class C, the first octet ranges from 192 to 223. These addresses are suitable for small networks, like those in homes or small offices. Class D, the first octet is 224. These addresses are reserved for multicast groups, which allow data to be sent to multiple recipients simultaneously. Class E, the first octet ranges from 240 to 255. These addresses are reserved for experimental use and are not intended for general use. Network ID and host ID. A network ID and a host ID are 2 components of an IP address, which is a unique numerical label assigned to each device connected to a computer network. Network ID identifies the network to which a device belongs. It is determined by the number of bits allocated to the network portion of the IP address. Host ID identifies a specific device within a network. It is determined by the number of bits allocated to the host portion of the IP address. As we can see in the picture that all the network classes has different network sizes. Network ID changes when you change the network bits and host ID changes when you change the host bits. We can deduce from the picture that Class A has less number of networks and Class C has the highest number of networks. If we change the Class A network bits from 0 to 127, then we will have 128 unique networks. Network ID and host ID difference. If we take a Class C network like 192.168.0.0, here the network bits are 192.168.0 and host bits are 0. The host bit can change from 0 to 255. 0 will be added to the network ID. In this case, the first IP address of this network will be 192.168.0.0, which is the network ID. The remaining will be the hosted still 254 like 192.168.0.1, 192.168.0.2, 192.168.0.3, and so on till 192.168.0.254. The last IP address 192.168.1.255 is known as broadcast IP address. As we can see in the picture, we use 192.168.0.0 network here, which will have 254 host ID. We just need to change the last octet from 1 to 254. Devices with the same network ID are in the same network. These devices can communicate with each other without router. They communicate with switch or any other layer 2 device. Devices with different network ID needs a router. As we can see in this network topology, that we have one switch and 5 hosts. Host 1, 2, and 3 are in the same network, which is 192.168.0.0. Hosts 4 and 5 are in the same network, which is 192.168.1.0. I have assigned unique host ID respective to the unique network ID. Now we go to the command prompt of every host and check the IP address of every system. ipconfig is the command to check the IP configuration of the system. We see subnet mask and default gateway here, which we will discuss in the later videos. We can see that host 4 IP address lies in a different network, which implies that host 4 and 5 can communicate with each other but could not communicate with host 1, 2, and 3. Ping is the command to check if we can communicate with a device with some IP address. I have pinged host 4 using host 5 and I see the reply packets, which means that host 4 and host 5 can communicate. Now, let's try to ping host 1 and see the result. We can see that there is no reply packets and the ping request is timed out. We can deduce that devices in the different networks could not communicate using the switch.